Well, here we are, another episode of Heat Treat Radio. I'm your host, Doug Glenham, the publisher of Heat Treat Today, and get to be the host of Heat Treat Radio, which is a lot of fun, actually. And you can find out more about Heat Treat Today at heattreattoday.com. Today, we are welcoming back a guest we've had on Heat Treat Radio several times, Michael Mouilleseaux from Erie Steel Treating in the Toledo, Ohio area. We're going to be talking about some energy policy things that are impacting captive heat treaters, commercial heat treaters, heat treat industry suppliers, all of those folks. Should be a pretty interesting conversation. In way, though, of tooting Michael's horn, I would just like to say that he's really our resident expert on this. He has published, and in fact, I've got him laying out here in front of me right now, 5 columns over the last 2 years on U.S. DOE, Department of Energy, strategies, decarbonization efforts, all different types of things. Even wrote about, what's going on under Trump. So we're going to talk a little bit about that a little bit later. So he's quite qualified in this area. And also, Michael, as we discussed earlier, you are the, the chairman of the MTI Regulatory Impact Task Force, MTI being the Metal Treating Institute. So that activity is still going on, correct?
It is. We have an activity taking place in California right now, and hopefully we can report out on that in the next couple of months.
Okay, great. I know that's an important effort. I was at the most recent MTI meeting that we had, and there was a lot of discussion about that, the craziness going on in California. So it's nice to know the MTI is on top of that. So let's start out. You've got some pretty interesting statistics about pollution, let's say, sustainability, and things of that sort. I think that's a great place to start. Do you want to share some of those stats with us?
Yeah, this is kind of a wonky subject, as it were, and there's a lot of statistics that go into it. Maybe we could just talk about a few of them at the outset of this thing, and as we revisit them during the course of this, and make a little bit more sense. So the United States represents about 11% of the total greenhouse gas emissions, total. China represents 30%. India is almost equivalent with us. They're just under 10. Since 2007, so 2007 is said to be peak year for greenhouse gas emissions worldwide.
Okay.
Since 2007, the U.S. has reduced its greenhouse gas emissions 15%. During that time, we've increased our energy production by 45%.
Okay.
So obviously, we're doing something right.
Yeah.
In that same time frame, the rest of the world has increased their greenhouse gas emissions 20%. Okay. So when we talk about what is it that we're doing and what more do we need to be doing, we're doing more than anyone else.
Yeah. Yeah.
So in the U.S., what constitutes, what are the component parts of this greenhouse gas emissions? So you've got transportation, electric generation, and industry, and they're all about 25 or 30%.
Yeah.
Heat treating, as a small part of industry, represents 0.3% of the U.S. greenhouse gas emissions.
Total across transportation,
across everything,
all of that.
0.3.
Okay, 0.3%.
And we're going to have a conversation. Why us?
Yeah.
So a couple of facts. In the United States, natural gas costs less than $3 per million BTUs.
Yeah. Okay.
You go someplace like Germany, and it's $12.
4 times the rate.
4 times the rate. Now, there was a time in the U.S. when gas was that expensive. And I remember that. And that was not a fun time to be in the heat treating industry.
Yeah.
So the commodity cost, and when I just said it was $3.12, that's the commodity cost. That doesn't include transportation. That just that's the cost of the commodity itself. So electricity in the United States for industrial customers averages a little over 8 cents a kilowatt hour.
Okay.
That's nationwide. The puts and takes on that are then California, where you've got 20% renewables. It's almost 20 cents a kilowatt
Okay.
hour.
Yeah.
And in Germany, the reason I'm using that's the largest economy in the European Union. In Germany, it's over 30 cents a kilowatt hour.
Yeah. Uh-huh.
So a couple of interesting facts as we talk about what this legislation is and how it affects us. The United States Congress is composed, 40% of the United States Congress are lawyers.
Okay. Right.
Less than 2% of the members of the United States Congress are engineers.
Okay.
So here we have
Yeah.
this highly technical
Yeah.
discussion about clean air and the thermodynamics and these models that are used to generate the information that we're being held accountable for.
Yeah.
And we have less than 2% of the members of Congress even understand it.
You're right. Or who have some sort of a background in it. Right.
So how did this whole thing get started? It kind of goes back to the Clean Air Act of 1970.
Yeah. Okay.
And that was established, a national air quality standard was established. There are 6 named pollutants, and it covered the United States only.
Okay.
We're going to come back and visit that because that's significant.
Yeah.
In 1990, the Clean Air Act was amended by Congress, and it ended up including an additional 180 additional pollutants.
Okay. So what was the first number? It went from how many? 6 to 180.
180.
Okay.
180.
Right.
Okay. So do we remember what the 70s were like? And, if you do, you can remember seeing television shots of Southern California, and you couldn't see anything because the smog was so bad.
Right.
So was this legislation justified? I would say that it absolutely was.
Yeah. That and the Cuyahoga River being on fire, right? Stuff like that.
There you go.
Yeah.
There you go. So very important.
Yeah.
You mentioned earlier that we have this initiative. The MTI has this initiative in California. So why have we focused in on a single state? Just remember the fact that it was the Clean Air Acts in California in the 1960s that spurred the United States Congress to generate the Clean Air Act, which now has nationwide application.
Yeah. They say what
looking at
starts in
something-
California spreads to the rest of the nation and the rest of the world or whatever. Yeah.
It absolutely does. So we have the Clean Air Act. The second thing is in 2007. Okay, we've gone from 1970 to 2007.
Yeah.
The Obama administration took 2 things: a Supreme Court ruling, and then some information that was generated by what's called the IPCC. So that's the Intergovernmental Climate Change Panel.
Okay.
In this panel, a highly politicized body, by the way,
Yeah.
but they were the ones that came up with the information that said that with a certain amount of CO2 in the atmosphere, the Earth is going to heat up.
Okay.
If it heats up, we're going to melt the solar ice caps. We're going to have rising sea levels. We're going to have monsoons. A very catastrophic scenario was presented by this thing.
And that's in 2007?
2007.
Okay.
So based upon that, the Obama EPA had what they called an endangerment finding.
Okay.
Now, endangerment is not a scientific term. It's not an engineering term. It's a legal term. It means risk of harm.
Okay.
Not actual harm, but a risk of harm. So they took this information. They said there's a risk of harm to the U.S. population. And as a result of that, we're going to implement legislation. And the first legislation that came down the pike was the Clean Power Plan Act.
Okay.
So the EPA said to the states, you have to regulate the CO2 emissions of the power plants in your states. And at that time, the regulation, I believe it said that by 2030, so this is 2007, by 2030, the greenhouse gas emissions had to be reduced 30%. So you've got 13 years, right? No, 23
years. Yeah,
years.
23.
But if you reduce that, it seems almost reasonable.
And Mike, just to be clear, they said you need to reduce it by 30%, not to 30%. In other words, you don't need a 70% reduction. You just need to reduce it 30%.
Thank you. Yes.
Yeah. I was just wanting to make sure. Yeah.
Now we fast forward to 2021.
Okay.
And the Biden administration comes in. You know, it's difficult to describe this and not sound political,
Right.
but the years are what they are, and the people that are in power are who they were,
Right.
and this is the result of that. So in 2021, just as Biden comes into office, he issues an executive order mandating a clean energy economy.
Okay.
And he charged the EPA, the Environmental Protection Agency, and the Department of Energy to develop a plan to further what was the reduction in greenhouse gases.
Yeah.
So it affected all three segments of the U.S. economy that generate greenhouse gases.
Right.
So the previous Power Plant Act, that was updated, and it said that we had said the previous had to be reduced 30% by 2030. Under the Biden administration, the regulation was changed and had to be reduced 85%.
Okay.
And you had to have net zero emissions by 2050.
By 2050, yes.
So that applied to the power plants. It applied to the automobiles. So the transportation sector, that's where you saw we have all of these incentives that are in place. You know, there was a huge push for electric cars.
Right.
If you recall, they were supposed to have 40% of the vehicles sold by 2030 were to have been electric vehicles. And by 2050, it was supposed to be an all electric economy.
Yeah.
Same thought process going into play there. Okay. Now it also applies to the industrial sector.
Okay.
And there are five segments of the industrial sector: iron and steel, manufacturing, chemical processing, petroleum processing, food and beverage. How that got in there, I don't know. But all five of these segments of the industrial were subject to the same thing.
Okay.
That is that by 2030, an 85% reduction in greenhouse gases, and by 2050, a net zero.
Net zero.
Now, they came up with what they called the 4 pillars of mitigation. And isn't that a wonderful term?
4 pillars
Right.
of mitigation.
Only the government can come up with something like that. The pillars of mitigation were energy efficiency, the use of low carbon fuels, carbon capture, and
Electrification. Okay.
So we say, why heat treating? As we mentioned, it's 0.3%. And as I mentioned, the 5 target areas, you said, well, where did heat treating come into play? Well, there was a symposium held by the Department of Energy in the summer of 2023. And in that symposium, they had further defined what with the segments within these 5 areas that I spoke of.
Yeah.
And in the iron and steel industry, they made the determination that 63% of the energy that's used in the iron and steel industry is in process heating. And then they further segmented it, and they said heat treating is a significant sector in process heating.
Okay.
So almost as an afterthought, we get pulled into this thing.
Yeah.
Quick clarification question on that. When they talk about process heating in the iron steel, are they talking about steel making or everything downstream from it?
Both.
Okay. Okay. All right.
Both.
Yeah.
Yeah. It's all inclusive. So the mitigating pillars how do they apply to us? So energy efficiency. So I had a conversation with several furnace manufacturers, and my question to them was, if we looked at equipment that's 20 or 25 years old and compared it today,
Yeah.
how much more efficient is the equipment today?
Yeah.
So we're going to say that's state of the art. How much more efficient is that equipment than what we had that's 20 years old?
Right.
And the maximum would be 20%.
20% more efficient.
20% more efficient. Maximum. Not average. That's the absolute maximum.
Right.
So we're not going to get to our 85% reduction in greenhouse gases by a 20% improvement in efficiency.
All right.
So then the next element was low carbon fuels.
Right. That's the
And
pillar,
after you
pillar
made-
number 2.
Pillar number 2. So after you make your way through what they were talking about, and there's some discussion about biofuels and
Yeah.
things of that nature. But at the end of the day, it's all about hydrogen.
Right.
So what they wanted, and their goal was to utilize hydrogen in place of natural gas as a fuel source. So is it technically feasible? And of course, the answer to that is yes.
Right.
Okay. Where you run into the problem is how practical is it?
Yeah.
So there's only a couple of, so first of all, is there a distribution center, a methodology for hydrogen? Could you just put it in the natural gas pipelines and use it? And not as they're currently configured.
Right.
It would require some work.
Right.
But then the next question becomes, how are you going to generate all of this hydrogen?
Right.
So today, the way that hydrogen is generated is they call it a method called steam methane reform.
Reforming. Yep.
So you take methane, which is natural gas, and you heat it by using natural gas, and then you inject steam. So what you do is you strip away the hydrogen, right? Steam's H2O. You strip away the hydrogen from the oxygen. The oxygen you can put back in the atmosphere. The hydrogen you capture, and that's what you're going to sell.
Right.
So a couple of things with that. First of all, the cost of that today is about $15 an MCF.
Right. Whereas regular natural gas, we said was 3.
Less than 3.
Less than 3. The 5x increase in cost.
There we go.
Yeah.
Now, the other thing is you're using 2.5 MCF of methane or natural gas to make 1 MCF of hydrogen.
Okay.
So if you're not an engineer, you're just fine with that.
Right.
But to those of us that can do a little bit more than just add and subtract, it makes no sense.
Right.
It's nonsensical.
Yeah.
And the other part of that is there are no facilities that could generate the amount of hydrogen that would be needed to supply industry.
Right. And Michael, so you're using twice. You're using 2x on the fuel to make it, but also doesn't hydrogen have like a quarter of the BTUs of natural gas or something like that? It's
so it does. You have to use 2.5 times as much. That's why I said
Gotcha.
I said MCF. It's per MMBTU per million BTUs of energy.
Gotcha.
So it takes 2.5 million BTUs of energy of natural gas to generate 1 million BTUs of hydrogen.
Yeah. Yeah. Something wrong here.
So there is another way. There is another way of generating hydrogen, and that is electrolysis.
Electrolysis. Yeah.
So again, you take water with a sufficient amount of electrical input. Again, you can strip the hydrogen off the oxygen.
Right.
You can use a membrane sieve.
Right.
You can separate them out. Well known, well established, been done for quite a long time.
Yeah.
So 2 things that you have to consider with that. The electricity that you use, where does it come from? So in this country today, 40% of our electricity is generated from natural gas. So if you are going to say that we are going to reduce the CO2 output and you're utilizing natural gas to generate electricity, there is an issue there.
Right.
The second thing is the cost. So the cost today of electrolysis generated hydrogen is about $60 per million BTUs.
Okay. So just for those who are $3 for natural gas for the BTU quantity you said, $15 for methane separated, and $60 for electrolysis separated.
Right.
Okay.
So that's today. Now the industrial roadmap that the Biden administration came up with, they said, well, what we're going to do is we're going to use green energy. So we're going to have wind turbines and solar panels.
Right.
And of course, we all know that that's free. We'll talk about that in a minute.
Right.
We all know that that's free because the wind blows for nothing and the sunlight comes out and graces us with its presence every day. So that's free. So we're going to get hydrogen, a million BTUs of hydrogen, and the cost of that is going to be half of what the current cost of natural gas is.
Current cost of natural gas, so less than, meaning at about $1.50 or so.
$1.50.
Okay.
Now, if that isn't irrational exuberance,
Yeah,
I don't know.
you're right. Right.
Okay, so there are two other strategies. The third is carbon capture.
Yes. Right.
So carbon capture is a technology where you would take the CO2 that's emitted from a combustion process or others,
Right.
and utilizing molecular sieves and such, you would trap that. Sometimes they will generate dry ice out of it.
Right.
Other times you might just inject it into the crust of the earth.
Sequestration. Yep.
So today there are 54 carbon capture operations operating worldwide.
54. Okay.
Worldwide. This isn't in the United States. It's less than 10.
Okay.
Worldwide. And all of these things have to do with petroleum processing. So they're taking natural gas wells, let's say. You'll take the natural gas, you burn that, you'll generate the energy so that you can generate these sequestration efforts.
Yeah.
And that's how it's paid for.
Yeah.
There is nothing that is available today on a level that you would be using in a heat treating operation.
Right.
The carbon capture plants that you would look at, they take up acres. This is not a small, confined operation.
Right. So once again,
So then,
not
of course-
very doable, but not practical.
Correct. So the last is electrification. So we all know, are there electric furnaces today? And there absolutely are.
Sure.
We've had many presentations by furnace manufacturers that we've seen over the years. Most recent that I had seen is that an electric furnace equivalent to a gas-fired furnace probably costs 10% less.
Okay.
You might make the case that the maintenance on that would be less because you don't have as many moving parts and gas trains and all of that kind of thing.
Right.
But the operating cost might be 3 or 4 times what the operating cost is for a gas-fired furnace.
Okay.
So it's an economic issue.
So why do we say that 3 to 4 times the cost of electricity?
The cost of
Primarily?
electricity.
Okay.
Yes. So it's 3 or 4 times. So, I mean, we talked about the fact that the average cost of industrial electricity is, 8.5 cents in the U.S.
Right.
It varies. It varies from 5 to 25. So it may be less costly in some areas and more. I'm just looking at the averages on
Right.
things.
Sure.
So the other issue would be if you took all of the gas-fired equipment that you had in this country and you wanted to power it with electricity, how much would you need?
Yes.
And the answer to that is you would need a significant amount, and we don't have that amount of electricity available.
Right. Right. For sure.
Um,
And considering that the hot topic of the day is the data processing centers who are going to be sucking up a lot more electricity than we have even now. So it's not like electricity is going to be readily available within the next 5 years or so.
precisely.
Yeah.
And you look at these data processing centers, and predominantly they're using natural gas-fired turbines to generate the electricity. Many of them have their own power plants on site.
Yeah.
They have microgrids.
Yeah.
There are 2 or 3 of them that have made application to the NRC to use small modular nuclear reactors.
Right.
And these are the boys from Silicon Valley, who typically have been green.
Right.
And they recognize that that is not going to be the key to success.
Right. Yeah.
So even in their case, the practicalities of dependable, cost-effective power trumps the need to be
green,
or at least appear to be compliant with all of our climate requirements.
Yeah, exactly.
Yeah.
As Kermit the Frog said, it ain't easy being green.
That's exactly
Actually quite costly these days. So sorry,
Yeah.
that was my high school class song, just FYI. So, all right. So
what are the effects that
Yeah.
that this would have in industry? So, I mean, if you think about what we've just talked about, we're talking about destabilizing our industry
Yeah.
as a result of trying to use unproven technologies.
Right.
Other than electric powered furnaces, there aren't any of these things currently exist today, either on a scale or are cost effective,
Right.
that we could use to replace the power that we use in the heat treating industry.
Right.
So when we said, I mean, we talked about, a 5 times or a 20 times increase in cost. So power typically is about 10% of the cost of a heat treating operation.
Okay.
Okay. So where I get those numbers is that the MTI does an annual survey, and we talk about what costs are involved in the heat treating operation.
Right.
In power is always the second or third cost, and for the MTI it averages 10%.
Okay.
Well, if I have a captive operation, it's different. So I happen to have some experience in the captive industry.
Yeah.
I ran what was arguably the largest captive heat treating operation in North America.
Yeah.
In Syracuse, New York.
Okay. Gotcha.
We had 15 multi-roll pushers.
Yeah.
So to those people, would it matter if the cost of energy went up 5 times or something like that?
Yeah.
And it absolutely would.
Absolutely would.
Power was a huge concern, and we made many efforts in attempts to reduce the amount of power that we needed to do there.
Yeah. And you were probably
that-
happy if you could get it down 1% or 2%.
Yes, and that was one of those installations where efficiency was the way that we went about doing that.
Yeah. Yeah.
So when you have a heat treating operation that's supporting a large manufacturing operation, the heat treating operation is never the pinch point in getting out production. It's always the manufacturing operations.
Yeah. Gotcha.
So we ran extremely inefficiently to support those operations.
Yeah. Gotcha.
So we talked about destabilizing these things. The implementation schedule that we're talking about is unrealistic. So we're talking about in 10 years achieving an 85% reduction in greenhouse gas. And none of these technologies that we've talked about is that going to be achieved. And so the cost of that, so if it's destabilizing because it's unproven, it's destabilizing because the implementation schedule is unrealistic, and it's destabilizing because of the increase in cost.
Yeah. But Michael, there are some, Europe, for example, has done some of this, I mean, I think they've moved in this direction. You were talking about the price of energy over there. What about that?
So again, I happen to have looked at what happens in Germany.
Yeah.
Because Germany is 25 or 30% of the European economy.
Right.
It is definitely the big dog.
Right.
So we know that the electric power is 4 times what it is here. We know that gas is similar. So what has happened to the, and we all know that the German industry is an absolute powerhouse, or at least it had been.
Yeah.
So recent years, here's what's happened, and that is subsequent to the pandemic, they lost in their economy went down. They recovered, and since then, they have lost in industrial output 2 to 3% per year.
Okay.
Well, right now they are 10% below where they were.
Where they were at the bottom of the pandemic, or
Not at the bottom, prior to the pandemic.
Okay. Okay.
So you look at that and you say, well, wait a minute, what are the reasons for that? And Germany, I mean, do they make the best cars? They certainly think they do.
Yeah.
Do they have the best machine tools? They definitely think that they do.
Yeah.
Do they have the best chemical processing plants? They definitely think that they do.
Yeah.
I know for a fact that BASF, which is a large German chemical processing business industry, the last 2 chemical processing plants that they put in Louisiana. And I don't believe Louisiana is within the German Democratic Republic.
No, correct.
So when you look at that, the German central bank, the European central bank have all taken a look at these things. They issue annual reports on the various members of the EU. And every report that has come out in the last 3-4 years has specifically stated that it's the high cost of regulation and it's the high cost of energy that has been the cause for the diminishment in German industrial output.
Yeah. Very interesting.
So just one other thing, and that is when we talk about renewables, you have to understand that there's a risk of interruption of service.
Yeah, for sure.
So is it storied, the number of interruptions of blackouts that there have been in California? We really don't hear of them in this part of the country because it really doesn't affect us. But I believe that the number of blackouts in California last year exceeded 100.
Yeah.
Now, how long they are, but when you have an industrial process that's going on, it doesn't take much of an interruption to where everything has to be reset.
Yeah.
There's a potential of having damaged things, damaged equipment, certainly damaged product. All of those things have to be taken into consideration. Yeah. And let's think about Portugal. So another European country, I believe that 70% of Portugal's energy is generated by wind power.
Okay. On the coast.
Earlier this year, Portugal had a 2-day blackout nationwide. And it all had to do with the fact that power that's generated by a wind turbine. So neither wind turbines nor solar panels generate alternating current. They all generate direct current.
Okay.
You can put through an inverter, and it's got to be cleaned up. If it's out of phase, so here we have 60 cycles per minute. Is our alternating current. In Europe, it's 50 cycles.
Okay.
There's not a tremendous amount of variability that's allowed in that.
Yeah.
And so when things become off cycle, it shuts down the entire grid. And that's essentially what happened in Portugal.
Interesting.
And it took them 2 days to restart the country.
Yeah.
There's a cost there that I understand what the goal is.
Yeah.
I'm just questioning the methodology and how you get
right. And once again, the practicality of it. Right. So that's so much for the Europe. If Europe is teaching us anything, they're showing us the mistakes, and
exactly.
And, maybe not even mistakes, right? Maybe just the outcomes, whether they be intended or unintended outcomes of moving in that direction. So,
and in all fairness, it's moving in that direction too quickly.
Yeah, right.
I don't think that there are any of us who say that this goal is not admirable. It's not something that we want to accomplish.
For sure.
The question becomes, how do you go about doing that?
Right. Right. And thinking about that, then I'd like to go on and talk about what's going on nowadays, but there may be different reasons why they're moving too quickly. I could see in Europe, especially Eastern Europe, why they may be moving quickly away from gas, right? I mean, with the whole Russia-Ukraine thing and the fact that they get most of their gas from there. Okay, I can see that. And that I would consider to be somewhat of a market effect, even though it's, based on war. It's not something that was imposed from authorities and things of that sort. It's an outcome of a event.
Well, Doug, I would suggest that that's a self-inflicted wound.
That very well could be, yes. But it's not, but it's,
Well, if you're going to hitch your wagon to Vladimir Putin,
yes, right. But you can see why they'd be moving quickly that way. The rest of the country and the fact that we're trying to convert so quickly to electricity is self-inflicted by regulation primarily. So,
yes.
Well, that's interesting. So what about now? I know there's some changes here recently in the States. What about that?
Well, almost everything that we spoke of that happened during the Biden administration was achieved via executive order.
Yeah.
So the interesting thing about executive orders is that you issue an executive order, and then you're no longer in office, and I'm the chief poobah.
Yeah.
So I issue an executive order that overturns everything that you have done.
Right. Exactly.
So I recently looked at a paper that was done by the Institute for Energy Research, and they said that this was through September that the Trump administration had 20 regulatory actions or executive orders that were related to energy production.
Okay.
So most of them overturned, rescinded what was in that industrial decarbonization roadmap.
Gotcha.
Now, there were a couple of things that were actually codified in the Biden administration, and that is in the IRA, the Inflation Reduction Act.
Yeah.
If there's ever been a misnomer,
Yes, exactly. Yeah.
there it is for us.
Yeah.
But what that act, amongst other things, what it did that was energy related is they implemented an investment tax credit and a production tax credit. So the investment tax credit relative to renewable energy gave you a 30% tax break on all investments that were in renewable energy.
Okay.
And the production tax credit gave you a credit for every kilowatt hour of energy that you produced.
That you produced?
So if I have a wind turbine that's generating 200,000 kilowatts,
yeah,
and I'm getting back from the government 3 or 4 cents.
Yeah, gotcha.
All of a sudden I have, and I've purchased that equipment at 70% of what it cost.
Yeah.
All of a sudden I have the ability of undercutting what the current power plants are asking.
Gotcha.
Power that they're generating. So did it displace capitals? First of all, tremendous displacement of capital. So people are going to say, where am I going to put my money? So if I put it into this and I'm buying it for 70 cents on the dollar, that's a pretty good investment. Right. And I'm guaranteed that I'm going to get so much money from the federal government for the energy that I generate.
And Mike, just to be clear, it's not the excess energy that you produce. I mean, it could be energy that you produce and you use. You're getting paid by the government to produce your own energy.
Yeah, so that's more of a home thing. I mean, residentially, but this is on an industrial scale. So huge wind farms that you see.
Yeah.
They're put in place simply to sell energy to the grid.
Gotcha. Okay.
So it displaced capital.
Mm-hmm.
And so the other thing that happens is that when they are generating electricity, the base load plants that we have that are from natural gas or whatever it is, they're not able to sell their power. So they have to curtail down or something. The issue becomes when the wind stops blowing or the sun isn't out.
Yeah.
Where does that energy come from?
The base load.
So it has to come from those plants. So you're taking plants, and typically the way that these things is, the operating principle on them is they're going to run for 80% of the time or something like that. So if I can run 80% of the time, I know that I can generate this amount of power. I have these costs, and this is what we're going to sell it for.
Right.
All of a sudden, it's telling me that I got to do it for 20% of the time.
Yeah.
The cost structure changes.
Right. Right.
And of course, these are all public utilities that are are regulated, not just federally, but in each state.
Yeah.
The regulations are onerous and in Byzantine, trying to figure out what this is.
Yeah. Yeah.
Well, one of the things that you see is that for those of us that purchase power for industrial use, what you see is that peak cost of electricity, the cost for those things have risen dramatically.
Okay.
And the reason for that is they have to have some way that they can recapture these costs.
Make up for the fact that they're not producing the same amount of electricity all the time. Yeah. Right.
Right. So back to the investment tax credit and the production tax credit. So the big, beautiful bill that was, HR1 that was signed on July 4th,
Yeah.
that rescinded these tax credits.
Okay. Okay.
Now, it didn't rescind them immediately. Most of the rescission takes place in 2027 and 2028.
Okay.
So one of the things the Democrats did that was very smart is that they made sure that most, if not many of these renewable energy installations were done in red states.
Okay.
So if you're going to rescind these acts, it's going to be very difficult and painful politically for the red state politicians to do that.
Okay.
So as a result of that, they didn't end that immediately. They pushed it out. Now, as you know, for automobiles, the incentives for electric cars ended at the end of September.
Yeah.
It'll be interesting to see just what's going on there. The Europeans have some experience with that. The Germans ended their tax credit and they cut the electric car market in half for a while.
Right. Right. Elon Musk wasn't very happy about that. It was one of the sources of a spat between him and the president, I guess. So yeah.
So the investment tax credit and the production tax credit were sunsetted in 2028. But by executive order, he did something else, and that is he changed the eligibility requirements for it. So previously, under the prior administration, if you had 5% of a project completed, then you were eligible to receive these tax credits that I just spoke of. 5%. So you could have a plan, and you could have a place that you wanted to do it. You didn't even have to have purchased the land. You didn't have to have purchased the equipment. You just had to have a good idea, and we're going to give you the money for it.
Yeah. Huh.
So he changed that to where the program had to be completed 20%. So now you have to have purchased land. You have to know where you're going to put it. You have to have contracts for equipment. So although it didn't achieve exactly what you were hoping to see done, it was successful in that regard.
Yeah. Right.
So the last thing is that this administration has done, and it may well end up being the most significant, is that the EPA has made a plan to rescind the 2000 endangerment finding.
Yeah. The one that we talked about way at the beginning. Yeah. Right.
So the endangerment finding identified greenhouse gases. So the original charter of the EPA was 6 named pollutants.
Right.
And this 2007 endangerment finding identified greenhouse gases and specifically CO2 as a pollutant.
Yeah.
Now, the reason that I said that in the original finding is that it applied to the continental United States, is that this finding, the 2007 finding, references global warming, the global climate change.
Yeah.
So obviously, one of the things that they're going to attempt to overturn this is going to be on the basis that they have simply overreached what the original charter of the EPA was.
Yeah. Yeah.
Now, understand, it's complicated, of course.
Yeah.
So understand that in 2014, the activist Supreme Court that we had at that time did find that it was within the purview of the EPA to control greenhouse gases.
Right.
So on that basis, they said, we have a green light and this is what we're going to do. And you can see what's transpired prior to that.
Right.
This current Supreme Court, what they have said is there was a finding, and it was called the Major Questions Doctrine. And the Major Questions Doctrine says that a regulatory agency cannot dictate policy above and beyond what is in their original charter.
Okay.
So when I said that they're going to go after this agency on the basis that they're claiming that CO2 should be controlled because it leads to global warming.
Right.
That isn't in the original. The original charter says only what happens within the United States.
Gotcha.
And the other piece of that is that the science that was used in the original 2000 or 1970, no, it's 2007.
2009.
The 2007 endangerment finding. The science that was used for that was by this international organization, the IPCC,
Right.
Intergovernmental Panel on Climate Change.
Right.
So this panel, they don't have singular findings; they have groups of findings.
Okay.
So it's scientific, and based upon scientific models.
Right.
So they say if this happens, then it would lead to this amount of increase in temperature. If that happens, it could lead to this. So there are the scenarios within that are many and varied.
Yeah.
And what the Obama administration chose is they chose not the average,
The most drastic.
the worst case.
Yeah. Worst case scenario.
At least one of the worst case. This has been done. So again, what the current administration is doing is they're reviewing that, and they're saying that there is evidence now. So first of all, the evidence that you used did not come to fruition.
Right.
That's pretty damning evidence in and of itself.
Right.
And here's some new evidence, and this says that we don't have anywhere near the issue that you thought.
Right.
And probably the one thing that was never taken into consideration is the resilience of people.
Yeah.
So let me see if I'm going to have an increase in sea level, maybe I move to higher ground.
Yeah.
I mean, there are just so many things that were never taken into consideration. Now that we see that that's how people react to their environment,
Yeah.
that it is nowhere near the difficulty
Yeah.
that we thought.
We're not going to stand on the seashore and drown as the water creeps up over our nose in over a 5-year span.
Right? Thank you.
We're going to move.
And having said that, this rescission process is going to take 2 or 3 years.
Yeah.
You have to know that the environmental industrial complex is going to do everything within their power
Right.
to make sure that legally that this doesn't go through.
Right. Right.
So I say the environmental industrial complex. The environmental industrial complex is $100 billion industry composed of thousands of NGOs
Yeah.
that are interlocked, intertwined, and there are 100,000 people that are involved in this.
Okay.
So this is not just, the guy on the corner with the sign that says
Save the planet.
exactly.
Yeah.
This is an industry, and it has all of the machinations that would go on with these things, and their self-preservation is number one.
Right. So they're gonna do all they can to maintain the level of crisis in order to keep their business afloat.
Right. Now, If this effort is successful,
Yeah.
this will change forever what the EPA will and won't be able to do.
Yeah. Okay.
So it's very important.
Gotcha.
So as consumers and members of this republic, I think that it's incumbent upon us to make sure that our representatives support this effort,
Right.
so that they know that although they're up against a significant foe here,
Yes.
that they have the support of the people.
And entrenched, right, for sure. So Michael, all super interesting, by the way. You're as suspected, you're a wealth of information. So we've got this current situation. What's going to happen? And it's going to be a long fight to change the basics. Any concept of what we need to do in the short term, just over the next couple of years or so?
So I think that we really need to recodify the EPA charter.
Okay.
So if this endangerment finding is overturned, that is one way, and that this situation could be turned around.
Yeah.
The other would be if Congress were to revisit what the mandate for the EPA is and stated in legislation.
Yeah.
Because if it were stated in legislation, then this finding is of no consequence at all.
Right. Right.
And of course, the difficulty there is that you may get through the House, you don't have a filibuster-proof Senate,
Right. Right.
so it's that's obviously the challenge that we face on this.
Right. Exactly.
So, what's a rational policy for transitioning to non-fossil fuels?
Yeah.
So, first of all, this isn't a question of should we do this.
Yeah.
Well, is global warming a fact? And it is. Yeah. It is. There's no denying it. Now, the effects of that global warming have yet to be determined.
Right.
So what the climate folk don't want to tell you is that the increase in CO2 in the atmosphere also enhances farming.
Yeah. And plant growth and everything else. Yeah.
Exactly. That's not something that they want to talk about at all.
Sure.
They want to talk about whatever. And so climate is something that happens over a series of decades.
Yes.
So the fact that it's 100 degrees today is of no consequence whatsoever.
Right.
And the fact that you've had a 5-inch rain, just recently in this past spring, you saw on the news that we had monsoons in Pakistan. There was flooding and people died.
Yeah.
Well, I happen to be old enough that I remember seeing that on the news in the 1960s.
Yes, exactly. Yeah.
So this isn't something that's new. The flooding of those deltas, the receding of that, it's just part of the cycle of life.
Right.
In that part of the world.
Right.
So do renewables have a place in our power system? And they absolutely do, but not as a primary source. So the other thing about renewables is that, there's an aphorism that's used in the industry, and it's called dispatchable generation. And boy, that's a nice term, isn't it?
Yeah.
So dispatchable generation is what backs up renewable energy when it isn't working.
Gotcha. It's the more steady state energy producers.
So we said, well, we're going to do it with batteries. So today, for as many battery plants that have been put in place to back up renewable energy systems, there are still twice as many that utilize water pumping. So you pump water into an elevation that's higher from where there is a hydro plant.
Right.
And then when you need it, you drain that through the hydro plant and you generate electricity. So how does that work out? So let's say I have a renewable power and I'm going to run a pump and I'm going to pump water uphill.
Right.
And then I'm going to allow it to flow down. I'm probably going to have to pump it because you're not going to get enough, gravitational fall in this thing to generate this hydro plant.
Yeah.
So you're going to do that. So what are the energy losses in that?
Yeah.
Is it
Crazy.
20% or 30% or 40%?
Right.
It just, again, those are the kinds of things that you struggle to say, how do you make it work?
How do you make it doable and practical? It's certainly doable. You can do it, but yeah.
So a dirty little secret is this, and that is that if an average natural gas power plant generates 800 megawatts, okay, and it takes up 30 acres, that's stereotypical. 800 megawatts of wind energy takes up 100,000 acres. That's 150 square miles.
Wow.
150 square miles.
Yeah.
You say, well, you can use that land for something else, and quite possibly you could use it as farmland.
Possibly, yes.
What you can't use it for is you can't use it for grazing land.
Yeah.
Because those wind turbines just drive the animals crazy. Seriously.
Yeah.
And
That's
I
interesting.
learned that.
It's interesting.
I learned that in the early 2000s.
Yeah.
Germany, when I had work that took me back and forth. And I mean, the Germans had onshore wind farms, and they had discovered that at that point in time.
Yeah. So you can't have them near animals. And certainly, I don't want to call humans animals, but the human species also would be driven crazy by them.
So the other thing that it does is it denudes the land. If you have ever been proximate to a wind farm, so if you visit one, the first time you look at it, it's kind of cool.
Yeah.
But if you have to live with it,
not
so much.
Not so much. Exactly. Yeah.
And the people that are putting these things in do not live proximate to these wind farms.
That's right. Yeah.
They don't have to put up with that.
Right.
That's a wind farm. 800 megawatts of solar.
Yeah.
10 square miles.
How many?
10.
10. Okay.
Square miles.
Yeah.
30 acres, 10 square miles.
Right.
Now the solar panels, you don't have as much open land at that point. So it really is difficult to use that for anything.
Not really anything. That's right. Well, that's interesting. We better wrap up, Michael. I'm just wondering, is there anything else that you've got on, like a near-term policy or anything of that could help us out? And then we probably ought to wrap up.
Yeah. In my mind, it's all about codifying what we've done at this point.
Yeah.
We can't leave it to executive orders.
Yeah.
Because those are reversible.
Right. And codifying it's going to be very difficult, as you already mentioned. We could probably get it through the House at this moment, but probably not the Senate. So it's going to be difficult. Well, that's great. Michael, thank you very much. That was a lot of information and very interesting. And I'm sure our listeners, viewers will find it very interesting. Thanks so much for being with us and sharing your knowledge.
My pleasure.
We want to thank the listeners also and viewers for taking some time to listen today. Again, we thank Michael for his time. You can contact Michael. If you're watching this, we'll probably put Michael's email up on the screen, so you should be able to see it. If you're just listening to this, you can contact me and I will put you in touch with Michael. My email address is very simply doug@heattreattoday.com. So feel free to email me. If you like what you hear on these Heat Treat Radio episodes, please feel free to give us a 5-star review or a like, whatever you do on your podcast platform. Your positive rating really helps us quite a bit, and we appreciate it. If you don't like what you hear, just forget we said anything about it. And also, if you have a topic you'd like us to cover on Heat Treat Radio, please feel free to drop me a note and let me know. We'll find somebody as equally brilliant and proficient as Michael. Hopefully, that'll be difficult, but we'll try to address your topic. So send that to me. Email me your idea at doug@heattreattoday.com. And this and every other episode of Heat Treat Radio is the sole property of Heat Treat Today and may not be reproduced in part or in whole without advance written permission from Heat Treat Today. Again, I'm your host, Doug Glenn. Thank you very much for listening.